Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X published on February 8, 2026, exactly 1 week ago. It introduces a framework called Align, where agents strategically use natural language gossip to build reputations, finding that reasoning models can achieve 100% cooperation in complex social dilemmas. The paper is titled, Talk, Judge, Cooperate, Gossip-Driven Indirect Reciprocity in Self-Interested Large Language Model Agents. And as we will see later, the results regarding how these agents handle malicious actors are really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. To set the stage, Figure 1 illustrates 3 ways agents can track behavior in the donation game. On the left, we have private monitoring, where only the donor and recipient see the action, making reputation impossible. In the middle, perfect public monitoring assumes every agent magically observes every transaction, which is theoretically simple but unrealistic. The paper focuses on the third model, imperfect monitoring via gossip. Here the action remains private, but the recipient broadcasts a message to the community, allowing reputation to form through social communication. So Figure 4 details exactly how that communication works through a hierarchical gossip protocol. Instead of using simple binary signals, the system lets agents choose from 5 tones that correspond to different levels of verbal confrontation. On the low end, we see praising and neutral messages which acknowledge cooperation without aggression. But as we move right, the rhetoric escalates through mocking and complaint up to harsh criticism. This spectrum allows the community to enforce norms by socially punishing bad actors with negative judgment rather than just reporting facts. Having defined the gossip tones, Figure 3 now unveils the generative architecture. It splits the agent into 2 flows, an action module for decisions and a gossip module for evaluations. When acting as a donor, the action LLM uses history to choose a move, like cooperating to build reputation. As a witness, the gossip LLM generates public messages, selecting a tone like praising or criticism based on what it saw. Crucially, both tracks include a reflection step, shown on the right, where the agent reasons about maximizing long-term self-interest before updating its memory. So, putting those components together, Figure 2 maps out the full decision process over time. On the left, at time t, actor A performs a cooperative action, which witness B observes and immediately broadcasts as a positive message to the community. In the center, the audience receives this gossip, enabling agents who are not present to update their beliefs. Then, on the right, at time t plus k, Agent C relies on those public messages. Through reflection, Agent C decides to cooperate with Agent A specifically because of that past generosity, which effectively closes the loop of indirect reciprocity. Alright, while Figure 2 showed how the loop works with gossip, Table 1 establishes the baseline by removing communication entirely. In this infinite horizon donation game without gossip, the results reveal a fascinating split. The reasoning models at the bottom, such as DeepSeek V 3.1 Reasoner and O4 Mini, correctly identify that defection is the optimal strategy, showing 0 cooperation across the board. In contrast, the chat models in the top section are less strategic. GPT-4o Mini, for example, still cooperates 36% of the time, acting helpful even when there is no reputation system to reward it. So, while Table 1 showed reasoning models defecting in silence, Table 2 reveals a dramatic shift once the gossip network is active. In this infinite horizon setting, the reasoning models at the bottom, like DeepSeek V 3.1 Reasoner, now achieve a perfect cooperation ratio of 1.0. This confirms they are not inherently selfish, but rather highly sensitive to incentives. They defect when anonymous, but cooperate fully when reputation is at stake. Meanwhile, the chat models up top also maintain high cooperation, with GPT-4o Mini reaching 99%, showing that gossip effectively aligns the whole population toward mutual aid. So, Figure 6 translates those cooperation rates into actual payoffs, comparing average discounted returns in the donation game on top and the indirect reciprocity game below. The blue bars represent aligned agents with gossip, while the orange bars mark the non-gossiping baseline. Focus on the reasoning models at the top, like DeepSeek Reasoner and O4 Mini. Without gossip, their returns are stuck at 0, because mutual defection yields nothing. But, with gossip, their blue bars extend fully to the right, showing that reputation systems successfully turn cooperation into the most profitable choice. Wrapping up, the big takeaway is that decentralized gossip enables self-interested agents to cooperate without central control. We also saw that stronger reasoning models are actually better at this strategic alignment than standard chat models, This suggests future AI ecosystems could effectively stabilize themselves through reputation alone. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.